Hello, we are now on the last lesson for our expansion kit. So the last two lessons before this gave us a few more ways to be more efficient in proving. This time we shall return to the truth table and I shall offer you a more simplified version of the truth table, which I guess will help us be more effective in showing that an argument is indeed invalid. This is, of course, lesson 16. Now let's just review the basic idea of the argument. Okay, we already said that an argument is either valid or invalid. And when true premises always lead to true conclusions, the argument is valid. And we've already pointed out that the argument must work all the time for it to be valid. But given an instance when true premises lead to a false conclusion, the argument is invalid. And an argument is invalid if it fails only once, at least once. Now, on valid arguments, we must also take note that this is the exact same principle that we follow when we write proofs. Every statement that we provide in the proof must be true, like true premises, drawn from true premises, so that we will arrive at a true conclusion. But we also know that you could also prove an argument valid by constructing a truth table. Maybe now it's the time as well to evaluate the advantages or perhaps disadvantages of these two methods. Of course, we know of the many challenges of writing proofs, but writing a truth table, constructing a truth table, also has its own challenges, and I'd rather, say that these are bigger challenges compared to writing a proof. Because number one, you have to fill up every box on the table accurately. Number two, you have to make sure that all the possible combinations are present and accounted for, especially in terms of the basic letters on the number of rows on the truth table. And thus, this also leads us to think that if the table were bigger, the greater the chance of committing errors. So we'd rather just write proofs rather than construct a table if we wish to show that an argument is valid. So remember the formula here. If you have 4 letters, 5 or 6 letters, imagine how many rows of the truth table you need to construct. That's also one reason why the truth table becomes rather cumbersome, time-consuming. Now, let's take a look at invalid arguments. And I guess we'll have to admit that, well, here is a sample truth table, okay? We've already seen this way back from lesson 7, okay, where you give the argument, construct the table, and looking at where you have true premises, you see if the conclusion will also be true, and in case there is at least one part of the table where true premises lead to a false conclusion, that would be enough for you to show and say that the argument is actually invalid. And perhaps you've already thought about it, right? You go through all the trouble of filling out all of these boxes of the truth table, and you're actually just looking for one. I guess if you can find 2 or 3 lines where true premises lead to false conclusions, that's well and good, right? But all you really need is to find one row in the truth table where true premises lead to a false conclusion. All of that trouble just to arrive at a single line, a single false judgment. And so, at this point, we ask, is there a way to find where the argument fails without needing to construct the entire table? And this is what the simplified truth table, that's what we shall call it, will do for us. Okay? Since an argument is invalid, if it fails at least once, I only really need to find one row on the table where true premises lead to a false conclusion, as already stated. And so the simplified truth table helps us arrive immediately at that single row that we need. And also, you don't have to construct the entire truth table. Imagine, again, if there are 4 basic letters or 5, or 6. Imagine how big the truth table is going to be, filling up so many boxes, only to need just one row where true premises lead to a false conclusion. So let us then introduce the simplified truth table. So here is the truth table again, the same example from a while ago. And I've already noted that all we really need is this single row right here, where true premises lead to a false conclusion. Can we construct a truth table in such a way that we could immediately arrive at this single row that we need in order to show that the argument is actually invalid, thus making our construction of the table more efficient, time-saving, and effective? Okay, this still follows the same principles, okay? We're not going to change any of the principles of the truth table, but we're only going to change its construction so that we'll only be dealing with the line in the truth table, with the row of the truth table that we really need. So here is how it will go. So construct a table containing 2 columns, and the number of rows would be depending on how many lines the argument will take. In this case, there are 2 premises and, of course, 1 conclusion. But still counting in the word given and prove, you need 5 lines, 5 rows for the argument to put in. And then add a few more rows after the argument for the basic letters. Okay, so that's how many rows there will be on your simplified truth table. Notice that if you do this very first step, you're also already stating the problem. And so placing the argument on the table this way will also function as the statement of the problem. Next, fill up the rest of the left column with the basic letters. Of course, make sure that this list is complete. Looking at the argument again, we see that there are only 3 letters involved, namely B, X, and Y. And so make 1 row for each one 1 row for B, 1 row for X, 1 row for Y. Now it's time to take a look at or fill up the right column. What would the right column before? Now, we begin with the conclusion. Okay? We know that true premises leading to a false conclusion will show us that the argument is actually invalid. And so the first step to make would be to make the conclusion false. So in this case, X implies Y. It is an implication. And we all know there's only one way to make an implication false. You have to have a true antecedent and a false consequent. And so assign the value of true to X and false to Y so that X implies Y becomes a false statement. I hope it would be helpful for you if I put colors on the basic letters in the statement of the problem, in the argument itself, so that we can see immediately that if it's colored green, it's true. If it's colored red, it is false. Okay? And the same value that you assign to the letters in the conclusion will, of course, be the same value that you will assign to the same letters in the premises. At this point, we're only dealing with X and Y because X and Y are the only letters in the conclusion. Okay, in this step, our only objective really is to make the conclusion false, and it's necessary to assign truth to X and falsity to Y so that the conclusion becomes false. But this also affects the same basic letters in the premises, and so even in the premises, we'll have to be consistent and say that X is true and Y is false, following what we have over here. Okay. What's the next step? The next step is to assign values to the other letters to make sure that the premises remain true. And in this case, we only have B to worry about because we cannot change X and Y anymore, right? You've already seen that X has to be true and Y has to be false for the conclusion to be false. And so going to the premises one by one, if X or Y we already know is true, okay, and B is the antecedent here. Actually, for the first premise, it's okay for B to be true or false. However, we see, judging from the second premise, that B will have to be true for X implies B to be true, because X is true, X is the antecedent here. If you have a true antecedent in your implication, you also have to have a true consequent for the entire implication to be true. So I guess you don't have any choice, right? B will have to be true. Notice here what happened. By assigning the following values to B, X, and Y, namely B is true, X is true, and Y is false, we have made the premises true while keeping the conclusion false. True premises leading to a false conclusion. And as usual, of course, you end your truth table with a proper judgment. You say in the end, therefore, the above argument is actually invalid. Now let's go back to the truth table that we already know and compare it to that truth table. Okay, remember this? Okay, of course, I truncated the table already, removing all of those lines that are unnecessary on the truth table. And you see here that in the simplified truth table below, you're also already zooming in on the proper data so the true premises will lead to a false conclusion. And here you notice that the data are exactly the same. Namely, B is true, X is true, and Y is false. Leading, of course, for the true premises to give you a false conclusion. Same thing here. True premises lead to a false conclusion. And therefore, the argument is indeed invalid. I guess there won't be any more need to put down the definition of an invalid argument. Okay, I only ask you to do that in lesson 7 so as to remember the definition. But at this point, okay, I guess I can say that you are already experts, and so it's enough for you to say in the end, therefore it is invalid. But remember, the judgment here is important. And so we can do away with what we have here on top and actually just submit what we have here at the bottom, what we now call the simplified truth table, to say that indeed the given argument is invalid. And so this is how it must appear, okay? If you may give your answer to a quiz, for example, all you need to do would be to have a statement of the problem, basic letters, their values, and you also show that true premises lead to a false conclusion. Therefore, with the judgment, you end with the judgment that it is indeed invalid. Now, while working on the values for the basic letters, always remember the sequence. Always begin with the conclusion. Make sure to make the conclusion false. And then, of course, make the premises true, as already shown to you a while ago. But there is an arrangement here, okay? You have to begin with single letter statements, okay? Because if a single letter appears as one premise, you immediately have to assign that single letter as true for that premise to be true. And then go on to conjunctions, thinking, of course, that conjunctions need for both elements to be true. For example, A and B. For A and B to be true, A has to be true, B has to be true. You have no choice in the matter, right? To make sure that the conjunction is true, all of its elements must be true. And then after you're done making conjunctions in the premises true, you go to the disjunctions. Here you have a little bit of freedom, right? Because, well, if both elements of the disjunction are true, that's well and good. But all you really need is just one element of the disjunction to be true for the entire disjunction to be true. And then lastly, go to implications. So let's give ourselves another example. And this time, you will see that in our example here, there are more basic letters. And so I guess you wouldn't want to construct the traditional truth table for this one. It will take a lot of time, a lot of effort, just to find a single line where true premises lead to a false conclusion. So let's now cast this same argument in the simplified truth table. So here we go, making sure that there is one row for every line of the argument. And then if you will count, how many basic letters does this argument have? H, I, P, Y, and X. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh no, there are 6. Okay. H, I, P, Y, and X. All right. So let's try it out. So put down the basic letters. Okay. 5. Okay, 5 basic letters. All right. H, I, P, X, and Y. All right. Next step is to make the conclusion false. The conclusion in this case is a single letter X. And so X will have to immediately be false. So let's make X false. And now I'm marking X as red so as to remember that every time X appears anywhere in the argument, I have to remember that X is false. Next, I go to the premises. Okay, assign the value of the other basic letters to make sure that the premises are true. And as already stated in the checklist a while ago, you begin with single letters. Okay, there aren't any single letters in the premises. So next on the list would be conjunctions. We have a conjunction here. And to make H and I true, we all know that H has to be true and I has to be true. And so you assign those values to H and I. H is true, I is true. Now I'm marking these letters as green in the rest of the argument to remember that every time I see H, I have to remember that H is true. Every time I see I remember that I is true. Since this is a conjunction, if both of the elements are true, the entire conjunction is true. So now I've made that first premise true. Next, after conjunctions, we go to disjunctions. And now here we have two disjunctions, and we've already assigned values to H and I. So if you look at this, H is true, and so not H is false. What will happen to P, or what has to happen to P? Since the first element, not H, is false, okay, H is true, but of course the negation of H is the opposite of H, and so not H is actually false. I have to make P true so that the disjunction not H or P becomes true. Same thing with not I or P, right? I is true, not I is false. Thus, I will need P to be true for not I or P to be true. And we're consistent here. Every time P appears, I remember here that P has to be true to make the disjunctions true. Finally, we go to the implication. We all know that if the antecedent of an implication is false, then the entire implication is true, right? But just looking at this particular case, just looking at the consequent first, X and P, we know that X and P, it's false, right? It's false. Because X is false, though P is true, X and P is false. And so in this case, you cannot make the implication, you cannot make the antecedent of the implication true, or else the entire implication will become false. So far you have H here. H is true. We've already assigned that a while ago. But for Y and H to be true, we all know now that, well, Y, okay, has to be false so that the antecedent will be false and the implication will be true. If you review that, if you assign true for Y, the antecedent will be true, but the consequent will be false. That will make the implication false. And so in this case, the only value that you can really assign to Y is really F, or false, because the antecedent has to be false so that the entire implication will be true. Now, If you're doing this on paper, you just have to find a way to mark the letters as true or false as you go along the way. All right. I'm only highlighting them with colors so that you can more easily see that in this presentation. But of course, if you will submit the work, again, don't forget, of course, to say that this argument is invalid. Okay. But when you submit the work, complete. Okay. Here's the statement of the problem. Here are the basic letters and their values. And based on the values of the basic letters, you've shown that all of the premises are true. True premises lead to a false conclusion. The conclusion is false. And this leads then to the judgment. Therefore, you know that this argument is actually invalid. Okay, the colors are not important anymore here when you're submitting the work or when you finalize the simplified truth table, because all you really need is to state the problem, give the values of the basic letters, and show that based on these values, true premises lead to a false conclusion, therefore showing that the argument is indeed invalid. Okay, so I hope that this clarifies a lot of things and makes you excited to go back to truth tables and to be more effective in showing that an argument is indeed invalid. You don't have to construct the entire truth table. All you really need is the single line. And thus, I offer you then for your consideration the simplified truth table. Thank you very much. And I hope you have fun applying this principle.